Today, let's talk about ABC 378 from problem E. First part is description. We are given an integer a, the length of it is n. We need to return this value. 1 less than L less than R less than n. Sum of I is larger than L is less than R AI. Sum of the AI modulo M. We are given an integer n and m. So this is the value we need to return. If we solve it directly, the time complexity will be n to power of 3. This is very high, so we need to lower the time complexity. This is a very direct problem. This is the first part. Next part, let's talk about solution. There is a direct way to solve it. Let's define a b means sum of I between a and b, ai. So we can set an array. The first elements will be s. After we process the ith step, after we process the s step, so we have the array. The first element will be s0, 0, s1, s0. Actually, it will be s0, m minus 1, s1, m minus 1, s2, m minus 1, till si plus m minus 1, m minus 1. So when we process the s step, we can add the ai to every value. Add. After we add it, we will get a new array. So the only way for us to do it is to sum of the array, but the time complexity is definitely very high. It will be square of n, so we need to reduce the time complexity. The answer is very similar with these kinds of way, but we need to do some optimization. What we need to do is define another array b. B0, B1, B2, Bm minus 1. There is another value, that means cumulation. The definition about the b and cumulation, that means after we add the b and cumulation, we will get the value s1 m minus 1 when we process the s step. So I s1 1 m minus 1, s2 m minus 1, s3 m minus 1, and s m minus 1 minus 1. So this is the definition about array b and the cumulation. So we only to maintain the array and cumulation, we will get the value. So the first thing, if we update the b one by one, so we cannot update the every element in the array b because it costs too much time complexity. The time complexity is very high. So the only way for us, another way for us to do it is update. Update is the cumulation. This is what we can do. We don't need to update the element in array b. So there are two steps we need to do, and after we process s step, it also can meet the definition about the array b and the cumulation value. The first step we need to do is bi will equal minus cumulation. Next step will be cumulation plus equal AI. So after this is what we to do in S step. After we do these two elements, the result still after S step, when we process the S plus 1 step, it also meets the definition about array B and cumulation. For example, after we update the cumulation, the S, that means B0 equal cumulation will equal S1 S0I. In addition, it will be S1I, and 2 will be S2I. Yeah, because cumulation plus equal AI. So after we process the two steps, it also meets the definition. For the last elements, that means for these elements, it will become Si minus 1I. For the last elements will be Bi plus cumulation equal Si I. So this is the way we step the cumulation value and add a new elements for array B, and we don't need to update every element or several element in array B. So it definitely can meet the time complexity requirement for this problem. This is the main part of the solution. In addition, we also need another process. That means when we calculate the sum of B, we will know after B plus cumulation, it may be larger than M. So after we sum of the B, we also need to do how many element is larger than M after do this operation. If, for example, if there are X elements is larger than M, so we must minus equal X plus M. Because they are larger than M, we must subtract them. So another problem will be how to calculate the X. There are two kinds of method. First is made a set. That means set B a set. Make the type of B as a set. So we can use the lower bound function to calculate how many elements is larger than M and calculate the X. We will get the value X. Second element is use the segment tree. Because the value of M is less than 200,000. That means, M is not very large, so we can make the value of B at the index of segment tree. So we can use segment tree to get the X. After this is all about the problem. So for every step, the solution will be first update the cumulation and B. Second thing is sum B. And the third thing is calculate x and make sum subtract equal x plus m. So this is the solution part. This is only 3 steps. Answer should be add equal sum of b. This is the solution about this problem. Next part, let's talk about complexity. For the term complexity, for the first part, for the update and some part, it will be on. For the second part, we need n plus log n because update the segment tree or set every query and update need log n time complexity. So the finally time complexity will be on log n. For space space complexity is also will be on because the set or segment tree use 2n space. Space complexity will be on. This is all about this problem. Thanks for your watching. If you have any confusion, welcome to submit a comment. Thanks for watching.